All right, so we're going to start out with the exponent rules. So we're going to review exponents in scientific notation today. Okay, those were our last, like, third and second and third, the last units. Okay, so this stuff should be pretty fresh in your mind. Okay, so our exponent rules. Negative exponent. So let's talk about that first block there. So if we have the rule that says a over b to the negative n is equal to b over a to the positive n. So what happened from the left side of the equal sign to the right side? It went from a over b to the negative n, and then all of a sudden it's b over a to the positive n. Lily, what happened? Yeah, okay. We took the reciprocal. We flipped over the fraction. That's the reciprocal. And then we changed the sign of the exponent. Okay, that's exactly what happens with negative exponents. That's it. You flip it over, and you change the sign to the exponent. Okay? So we have our examples here. 3 to the negative 2. What would that be equal to? Think about that 3 as a fraction. Okay, because it's 3 over 1. So do those 2 steps, Ethan.
1/3 to the second.
1/3 to the second power. Okay, what about the next example? 2/3 to the negative 3. Claire?
3 over 2 to the positive 3.
3 over 2 to the positive 3. You flip it, change the sign of the exponent. Kate?
Why did you put the first one in parentheses if there aren't parentheses?
Because we want to make sure that the whole fraction is being raised to the second power. Okay, good question. All right, so what about multiplying? The product rule. So it says a to the m times a to the n is equal to a to the m plus n. So somebody tell me what we did from the left side of the equal sign to the right side of the equal sign. Lucas.
You added the exponents.
Good. Okay. Like bases, add exponents. So let's look at our example. 3 to the 5th times 3 to the 8th. Do we have like bases there?
Yeah.
What is the base?
3.
3. Tony, what's the answer? 3 to the 13th. 3 to the 3rd times 3 to the negative 5. Do we have like bases? What's the base?
3.
3. Okay. So what's the answer? Somebody raise your hand. Ethan. Oh. Ian. Liam. I get it right.
Negative 2.
What to the negative 2?
3.
3 to the negative 2. Okay? Oh, let's take that one more step. What would 3 to the negative 2 be with a positive exponent? Bart.
Parentheses 1/3 parentheses 2.
To the second power. Yeah. Okay. So those other rules still apply. It just doesn't matter what you're doing to the problem. Okay. So those are equivalent. Quotient rule. Quotient means to divide. So when we divide like bases, what did we do with the exponents? We subtracted them. Okay. We subtracted them. Raise your hand. Okay. So example. 3 to the 9th divided by 3 to the 2nd. 3 to the 9th divided by 3 to the 2nd. Do we have like bases? Yeah. Okay. And Claire, what would I get? 3 to the what? 3 to the 7th. Yeah. Okay. Is 9 minus 2? 3 to the 8th divided by 3 to the negative 2. Still dividing. We have like bases. We're still subtracting. Be careful with this math.
3 to the 10th.
And how'd you get 3 to the 10th?
8 minus negative 2 to negative to the positive. So you're adding negative 2.
Perfect. Okay, you said it perfectly. Okay, you're subtracting. You have 2 negatives. 2 negatives make a positive, so it becomes 3 to the 10th. Power of a power rule. So meaning we have an exponent raised again to another exponent. Color. Okay. A to the m to the n power. equals a to the mn. So when I have an exponent raised again to another exponent, Tony, what do I do? And multiply the exponents. Okay? So we multiply the exponents. So 3 to the 4th to the 5th power. Lucas. What did it say here?
3 to the 45.
20th. Okay. 3 to the second to the negative 4. An exponent to an exponent. Roman.
3 to the negative 8.
3 to the negative 8. And who can put that with a positive exponent? Who can make 3 to the negative 8? Sarah. 1 over 3 to the 8th. Sure. Okay. All right, so that's exponents. Pretty simple. Now let's talk scientific notation. So 3.72 times 10 to the 8th in standard form. So right now it's in scientific notation. Remember, we have a coefficient times a power of 10. Okay, that's scientific notation. Standard form is what you see all the time. Okay. So 3.72 times 10 to the 8th. Is that going to be a really big number or a really small number? Really big number. Okay, because the exponent is what?
Positive.
Positive. Okay, so the exponent's positive. Okay, you can type this into your calculator. You can think about it in terms of place value. How many, let me ask this question, how many zeros do I need to add on to the end of this? Lily. I need to add 6 zeros because what am I doing? I'm moving the decimal how many places? Total. 8 times. So I bypass the 7 and the 2, and then I have to keep moving it 1, 2, 3, 4, 5, 6. 6 more times. So let's put some commas in there. There we go. 8.1 times 10 to the negative 5. Is that a really big number or a really small number? Small. Really small because the exponent is what? Negative. So now, what is that in terms of standard form? I have to the negative 5. We said it's a really small number. Claire?
0.000081.
Right. Because we're moving it, okay? Negative 5, I gotta make it smaller. Make my number small, really small. So there goes 1, and then I have to move it 4 more times, so I have to fill in those 4 zeros. So let's just flip it the other way. I've got a number in standard form. I want it in scientific notation. The coefficient has to be a number between what and what?
1.
1
and, okay? It can't be equal to 10, right? Okay. So, Garrett, what's my coefficient? 2.89. 1, 2, 3, 4, 5. Awesome. Times 10 to the 6th. Perfect. Guys, check your work. Type 2.89 times 10 to the 6th into your calculator and see if it equals what the problem gave us. That's an awesome way to check. Write it down, what you think it is. Go to your calculator, 2.89 times 10 to the 6th, and see if it matches the problem. Okay? Here. Oh, okay. Next one, somebody else. Is this number a really big number or a really small number? It's a really small number. Okay. So if it's a really small number, is my exponent going to be positive or is it going to be negative? It's going to be negative, so I'm doing a little forward thinking here. So what's my coefficient? What's my coefficient? Claire? 5.3 times 10 to the negative, and she thinks it's negative 5, is she right? 1, 2, 3, 4, 5.
Yeah.
Awesome, negative 5. So 35 times 10 to the 5th in scientific notation. Why is that not considered scientific notation? Garrett?
It's not from 1 to 10.
What's not from 1 to 10? The 35, the coefficient. So make it a number.
Oh, I did it.
Come on, everybody the wrong thing.
3.5.
3.5. No, because remember, I made it 3.5. Is 35 bigger or smaller than 3.5?
Smaller or bigger?
35 is bigger than this. So I have to make this exponent what? 1
Or more?
bigger.
What? I said it was 4.
Test it. Type it into your calculator. Type in 35 times 10 to the 4th. Go, do it. 35 times 10 to the 4th.
Wait, I forgot.
Do you get
Yeah, she did.
35 times 10 to the 4th? Okay, you should get this.
Yeah.
Now type in 3.5 times 10 to the 5th. Do you get that back again?
Yeah.
You should.
Oh, wait, is that even?
Okay, Claire.
For some reason, I remembered that instead of making it a 5, it would be a 3. I don't know why I remembered.
That's going to be in our next example. You'll see, okay? Because think about it this way, Claire. 35 is bigger than 3.5, so we have to make that exponent bigger than what it was.
Okay.
Okay? All right, next one. What's my coefficient going to be? Coefficient. Coefficient,
Oh, wait.
I need Roman.
6.
2.6 times 10 to the what? Is 2.6 smaller or bigger than
Smaller.
0.026? Is it bigger or smaller than 2.6?
It's smaller.
This number is smaller than that one.
Yeah.
Okay. So what do I need to do with that 5? Make it bigger or smaller?
Smaller.
I have to make it smaller. How many times, or how many smaller? 2 smaller, so what's it going to be? To the 3rd. So now, test it. Go to your calculator. Type in the original problem. 0.026 times 10 to the 5th. Get a number on your calculator. Don't clear it. Now type in 2.6 times 10 to the 3rd. Do you get the same thing? You should. Okay? We good? Guys, don't be afraid to write something down and then go to your calculator and check and see if you're right. If it's wrong, adjust it. Fix it. All right, flip it. Operations with scientific notation. So let's multiply. We all know how to multiply, we all know how to add, and we all know how to make it into scientific notation. So, multiply the coefficients for me. Julia, what's 4 times 6? 4 times 6, try one more time. 24 times 10, and it says add the exponents. Go ahead, Julia, what's 10 to the 8th times 10 to the 9th? Add those, yeah, to the 17th. Now we've got to adjust it, just like we just got done doing. What do I need to make my coefficient? 2.4. Is 24 bigger than 2.4? It's bigger. Bigger. So what do I need to make my 17? Bigger. By how many? 1. So 18. Division. Divide. Oh. What's wrong with that? What do I need to do with the exponents? I need to subtract. LIFO. Adjust. Okay? Ready? Let's do it. Divide those exponents. 1.8 divided by 3. Lily. 6.
0.6.
Type into your calculator right now. 1.8 divided by 3.
It's 0.6.
Yeah, 0.6, yeah.
See, look.
I don't think.
1.8 times
Oh, time.
divided by
Yeah.
What is it?
0.6.
0.6.
There we go.
There we go. Phew. Phew. All right. Times 10 to the what? Nope. To the what? 11.
Oh, yeah, it's 7 minus 4.
You got it. It's 7 minus 4. Makes it 7 plus 4. Do I need to adjust?
Yeah.
What do I need to make my coefficient? 6 times. Why do I need to adjust? It's 0.6. That's not between 1 and 9.
It's not a spell anymore, so you can back up.
So 0.6 is smaller. So I need to make this smaller by what? 1. Okay. We are going to straight up change the rules in this one.
Just the first one.
So we're going to expand. Then we're going to just combine. And then we're going to adjust. So who can tell me which one is bigger here? 2.5 times 10 to the 4th or 1.8 times 10 to the 6th? Which one is bigger?
1.8 times 10 to the 6.
And why?
Because it's closer, it's smaller. Smaller decimal means it's bigger.
No. What do we have to look at to determine which one is bigger? We gotta look at the exponents. So this one is the bigger one. Can somebody expand 1.8 times 10 to the 6th? Meaning write it in standard notation for me, Tony.
That would be
1, okay, 1/8, and then how many zeros? 4, 5, okay. Yes, okay. So now, 2.5 times 10 to the 4th. Somebody expand that one for me. 2.5 times 10 to the 4th. What is that in standard form? Come on, somebody else. You guys don't know what type of your calculator. Matt.
25,000.
Okay, so we've got 1, 2, 3, 5, 2. 25,000. Look the way I wrote it.
You went backwards.
So you replace that as an order.
I wrote it backwards, and I needed to make sure that the place values were in order. Think way back to elementary school.
I don't like elementary.
When you added or subtracted, you had to make sure you lined up place values. Okay, we had to have those nice little place value lines lined up. Now, go ahead, type it into your calculator, add those two numbers up.
Or you could just do it,
Or you could just do it.
It's pretty simple math. You just put the numbers where they're.
Sarah, what you got?
I think it's 1,008,000. I don't know. I don't know.
1,845.
Okay.
Wait, how would you read that?
I got the numbers.
Yeah, 1,825,000.
I had it right.
What is that in scientific notation? Lily. Times 10 to the 6. Beautiful. All right. Read over that first word problem and tell me, is it add, subtract, multiply, or divide? The first word problem. Type it into your calculator and add them. Okay? Lily, what is it? It's division. And what am I dividing?
The numbers.
That's what I'm dividing. Right, and I'm going to let you guys figure that one out. Go ahead and read the second problem. Tell me what operation is the second problem. What operation? Add, subtract, multiply, or divide. Sarah? It's subtraction. How much bigger? Or how many, about how many more? Now, subtraction has to be, okay, especially when we're talking about population, big minus small. So which one is the bigger number, Roman?
1.16 times.
That's the bigger one, minus, okay, that's the population of India, minus the population of the United States. Okay?
Is this accurate?
Probably in 2010. India definitely has a bigger population than the United States. Okay. So I want to write these in standard form. So 1.16 times 10 to the 9. How many zeros do I need to put onto that? I need to add on, somebody said it, 7. And now 3.1 times 10 to the 8th, I need to write it backwards so I can line up the what's? Place values. So how many zeros am I going to need to write? Do I need to put 8 zeros or 7 zeros? 7 zeros. 1, 2, 3, 4, 5, 6, 7, then 1, 3. And by all means, go yourself. Okay?